Okay, hello everyone. We're now finally set up. Today's talk is going to be about compromising and attacking and how we can attack and pen test an environment built on Amazon cloud. So first, I'm going to introduce myself, and then we'll see all the topics we're going through. We'll have some discussions, and then we'll have some live demos. So I hope to show some actual let's say, actionable information, live demo, and I hope it all goes well. So let's start. That's me, my traditional clothes. I'm from Kuwait. Everybody knows where Kuwait is? So which one's bigger, Kuwait or Singapore? They're both small. Kuwait is still bigger. However, Kuwait is mostly desert, so that's a different one. I used to work in Kuwait government. I built the BigEye smart card authentication cryptography government systems of Kuwait. Then I went on to other things, to the field of cloud security. I went on to specialize in consultation and training in the fields of web application security, API security, and cloud security. Just yesterday we finished our training course here at the conference about attacking securing APIs. You guys missed it, unfortunately. So that's who am I, and you can check my Twitter account. You can check my GitHub account as well. The question is, why focus on Amazon cloud? The reality of things as it stands today that most organizations are either already on the cloud or they're going to the cloud one way or another, whether they like it or not. It's just how the market forces are going. And currently, Amazon holds the lion's share of all the cloud infrastructure, more than 47%, I think, and it's actually rising. So they are, even though they're the oldest player in the cloud, they're still gaining more and more market share. So it's important for us as people in the information security field to have deep knowledge in the Amazon cloud infrastructure, because that's where most of the clients are going to be, or actually already are. So AWS services are actually well documented by Amazon. They are widespread. Amazon gives you services from file management to even satellites. Amazon actually has a service where they can give you satellite connections. So Amazon really does everything: file management, servers, data management, account control, and even though Amazon itself has really good security, physical security, networking security, in the end, the environments or the infrastructure owned by the clients is the responsibility of the client. So Amazon has something called the shared responsibility model, where Amazon does things for you. You don't have to worry about them anymore, and you still have to actually handle your own part of the security infrastructure. So for example, some regular attacks in networking do not work inside the Amazon environment. For example, ARB spoofing, that just doesn't work anymore because the Amazon environment is fully virtualized and it is controlled on the hardware level networking. It's fully controlled by Amazon, and you don't actually get access to that. So for example, ARB spoofing attacks, they just don't work anymore. IB-based security systems become much less effective because now everyone is running inside Amazon. So all the IBs by default are actually Amazon's IPs. So how can you distinguish between the trust level of them? So the old security model is slowly being pushed away off the edge, and you have to adapt to the newer ways of how you can handle security in an Amazon environment. So this is the shared responsibility model of Amazon. Amazon will handle hardware for you, networking, storage. You have to actually handle the customer data, access management, platform application itself, operating system patches. So it's really difficult to see. It's not difficult to see how much we are now having much less headaches about the environments we used to work on. If you used to work in a database data center environment, you had to care about air conditioning, you had to care about the fire controls, you had to care about physical access security, who's going inside the data center, who's going out, right? With Amazon, you don't have to focus on that. Amazon does that for you. You just have to focus all your time on your own applications and the things that you do best, which is your own type of business and your own business logic. So that's the shared responsibility model. Amazon handles things for you, you handle things for yourself. So we're going to discuss some attacks and how they can be, let's say, launched on your own AWS environment and how much it differs from the regular enterprise environments that most of us have been working on. Usually inside Amazon, you have main services that almost everybody uses. For example, S3. What is S3? Anybody knows what is S3? Huh? Buckets, like water buckets or what? S3 is the distributed file system inside Amazon. Remember how we used to have those huge file servers, and it was really a pain in the neck to manage and handle? Amazon gives you like an API level file system that is distributed across the entire world, and your server could be in Amazon inside the United States, and your other server could be in Amazon in, for example, Singapore, and they all see the file system as if it was a local file system, so they handled this hugely distributed file system, letting us, take care of the business itself and really lose lots of the headaches that we used to have with managing file systems the regular way. EC2 is the actual most important service inside Amazon. It's the actual servers. In Amazon, you can run virtual servers, they call them, EC2 images. EC2 means Elastic Cloud Compute. RDS is the database that is managed by Amazon, which means that you only put your data inside this database, and Amazon handles the OS updates, the patches, the backups for you. You don't need database admins anymore with this service. And we have Lambda. What is Lambda? Anybody tried Lambda before? Remember how we said that Amazon really allowed us to focus on our business, so we don't need to handle hardware? Well, someone says, you know what? Why should I also handle the software? I don't want to handle virtual machines, do OS updates, update my Linux environment, update my Windows environment. Why don't I just throw my code and Amazon handles everything for me? So that's the actual service. They call it function as a service. You upload your code files, your Python files, your JavaScript files, and Amazon will handle executing, compilation, and running of this code base for you. And you don't have to handle anything else. You just focus on your own code. So this is really a match made in heaven for developers. It allows them to focus on the things that they know best. This means that while lots of the threats we usually have in regular environments are gone, there are threats that are much in focus inside Amazon. For example, data theft. Amazon actually resulted in lots of data theft incidents across the entire world because of how easy it was to just set up your file environment and your data environment. So developers are just putting it all online for everyone to come and grab. Mining cryptocurrency on your environment, ransomware, things like that. So let's go directly to the good things. Elastic Cloud Compute is the main service inside Amazon. You have your servers inside Amazon, you just log onto them using SSH, for example, or remote desktop. And Amazon can run these services in a scalable way, meaning that, suppose that now it is your business hours, you need 10 servers running. It's just one configuration away. After the business hours, your servers suddenly become, instead of 10, they become maybe 2 or 3 or 5. So you pay less, and it's all scalable and automatic for you. So it's really easy to manage that. Imagine how we used to do that in the old days, in the regular environment. We had to provision and buy lots of expensive hardware. With Amazon, it's just one script away. In business hours, make the environment big. After business hours, make the environment small. And then you have less things to go wrong, and you have less things to worry about. So, of course, this has some issues inside it. For example, the actual hardware on which your servers are running are out of your control. Amazon will handle that for you. So your virtual server could be running on a hardware device, a virtual server by another customer, and you don't know anything about them. But Amazon will handle this separation for you, so you don't have to worry about it. So if you notice, a lot less worrying. So why do we have a talk about attacking Amazon? Well, because we have less things to worry about in the lower stacks, we have more things to go wrong in the higher up stacks, because it means we have lots of configuration and lots of big need to understand the different features inside Amazon, and they are unfortunately so big, so it's really difficult for someone to just be knowledgeable in all of them. We'll take some examples here. How do you attack EC2 services, for example? The EC2 servers, the Amazon virtual servers. Well, you attack them just like any other server, like vulnerabilities in the OS itself. Maybe you don't update much. Maybe you have applications running inside them which are vulnerable, for example, a web application. So if you attack an EC2 instance, the virtual servers inside Amazon, what do you get? Well, you can gain control of this environment. You can try and steal data. You can try to steal access keys, passwords to go inside deeply into the other resources in the environment. We'll see some examples. So let's now I'm going to explain what does it mean to run an infrastructure inside Amazon. When you have an EC2, a virtual server in Amazon, what components are there actually? First component is the instance itself, which is like a Linux server running inside some hardware inside Amazon. For you can run it continuously only for certain amounts of time. You can put it in a group that does auto-scaling. When there's heavy load, you have more servers running, and then automatically when the load goes down, your running servers actually, the number of running servers also goes down, so you pay less on your bill. You connect to these instances using your SSH key pairs, so just like regular server connection. And you can also, if it's a Windows server, you can just connect using RDP. When you configure the EC2 servers, you can make them run with a startup script called user data, which means that, for example, when you run the server, do updates, get the code from GitHub, do some basic automatic configuration. Another part is the AMI, the Amazon Machine Image. What it means is that your server is running from an image like a pre-configured Linux machine or Windows machine with some configuration, some applications built in. So you determine this and you configure this image, and then every time you run your servers, they run based on this image itself. So this means that while you are managing your Amazon environment, you actually don't care about the servers themselves. You can just kill them anytime you want. You bring up new ones because you update the image itself. And you can actually get the images officially from Amazon or your own images. And these images will have the updates. They should be kept updated. You should be aware of anybody trying to maybe backdoor your images, for example, because those are the images that's going to run the actual servers themselves. So the server is going to run based on the configuration inside this image. You have the EBS service, the Elastic Block Store, which means it's a cloud hard disk, basically. You can just attach it to any server, and it can contain your data for you. You can also, one of the most important components inside Amazon is the AMI, the IAM actually, Identity and Access Management Service. This is the authentication and permission system inside Amazon, where you can give roles and user permissions, user policies. So you can say, for example, those servers are only allowed to talk to these databases, and those other services cannot talk to these databases, and then you can just do segregation. For example, financial department servers don't talk to IT servers, and then you can just issue different permissions, custom permissions based on that. So it's the most important service in Amazon. It allows and gives the permission system to all other services running. Of course, when you attack an EC2 instance, as we said, it's nothing special. You can just use regular web application vulnerabilities. For example, OS command injection, remote file includes, SSRF. We're going to see this one later. However, even though they are just regular virtual servers, they have some special cloudish properties about them. So for example, the first one is the internal metadata service. Amazon, inside each virtual server, will run a special metadata service. It has an IP, but it's a local service on the server itself. If you access this web page from inside an Amazon server, you're going to see some metadata, some special information about that particular service. For example, the IP of the server, the user data script attached to the server, the role, the access keys that the server is using to access other Amazon services. So it could result in, for example, exposure of AWS credentials. We're going to see some examples of that later in a demo. So for this demo, I'm actually going to try a tool built by a company called Rhino Security Lab. They created an intentionally vulnerable EC2 image. We're going to see this one, a live one, and then we're going to attack it and use what we gain from this server to attack the actual or the remaining services inside Amazon. So we're going to try an image with a vulnerability. This is the page. Not a very beautiful design, but at least it's responsive. So now let's try the page here. It's called the URL fetcher. It just does one thing for you. It's a very simple page. It's not for sale. You just give it the password, then you give it a URL, and this service will fetch that URL for you. So it will go, not from my machine, but from inside the Amazon server, and try to fetch that URL and display it for me. So for example, I'm going to try google.com. Let's give it actually a full URL like this. And now it's showing me the page of Google itself. Maybe not the most beautiful way to look at it, but at least it works. So now we know that this service is actually responding to my request and going to fetch that remote resource from inside that server itself, right? So if this server is trusted or is part of an internal network, maybe I can ask it to look around in the internal network that is firewalled off from me. Is that clear what I said? So what I'm saying is maybe there are some internal services that are connected to the server, like for example, the internal cloud account of whoever's running this. And even though I can't reach them directly, I can use this vulnerable service as a gateway inside that network, okay? So let's try it with Google. When I tried it, Google was actually displaying for me that the Google Doodle, where they just make new images. Apparently they were, on Father's Day, they were celebrating falafel. So it was really, really strange for them. See, nobody cares about fathers, huh? Okay, so in reality, of course, this page is vulnerable to what we call an SSRF, server-side request forgery. It means that, what I just explained, it requests resources for you on your behalf from inside that seemingly trusted server. So we tried the page, HTTP page, right? What else can we try? What other protocols can we try except other than HTTP? So there are other actually non-HTTP protocols, for example, the file protocol. Anybody heard anything about the file protocol? Is that clear for everyone here? I think the podium is just blocking everything, right? So the file protocol, it's just a way to access the local file on the system itself. So why don't I try to actually read files from inside that server itself? So let's try it out, okay? I'll say file // and then it's a Linux system, right? So I will start with another slash, and then I will read the etc file, for example. So password file, and then we are reading the internal file of who? Of the server itself, right? So we're asking it to actually give us the files inside the server. So maybe we can try something else. Let's try to read the source code, for example, of the page itself. The page, usually they live on var www, then HTML /index.php, right? Usually. So now, this is the PHP code. As you can see, a really small piece of code. As I told you, it's not for sale, okay? So we can read some internal files. Let's see what else we can do. So we've seen this one. We've seen reading the file. Why don't we read the /proc file system? Anybody knows what is /proc in Linux? /proc file system inside Linux. Any idea? Okay. So maybe we'll just explain this one. /proc is a special file system inside Linux. Any Linux machine will have a special file system called /proc, where you can have access to the memory details of all the running applications and processes. This would allow you, of course, inside Linux, everything is like a file. So even the memory itself can be referenced as a part of the file system, including this /barq file system, which we can see, can give you things like the command line that was running the application. You know, when you run an application, you run the command line of the application. For example, MySQL, you say MySQL -h, the host name, and then -p, the password, for example. So sometimes you put passwords inside the command line, which would mean for you, if you were able to read the command line of the application, maybe you could see some passwords inside. So let's try this one in the demo, see if we can read the etc special file system. We'll say file, // and then /proc. And then I don't know the process number of my process, right? But the file system inside Linux can give me something called self, which would mean the own process itself. So I don't know the process ID. I don't have to. And then I would say command line. And now it's giving me the command line itself of the process. So I can see, I can try now to extract more services about, or more details about the EC2 server I'm going to attack. We can also even get the ARB cache table, so we can know more about the internal network on which this server is running. The ARB cache table will allow me to know the MAC addresses inside, running inside the local environment. So we can see that we can have lots of information coming from this small vulnerability, the SSRF vulnerability. We can now read more and more data about the target or vulnerable EC2 server I'm going to attack now. So as you can see, this SSRF vulnerability now is giving us access inside the server itself. We can have access to the files. We can also have access to something we explained before, the special metadata service. Remember it? The one we explained actually can have some details inside the Amazon server itself, right? It gives us information about the server itself, some juicy information we can use. So maybe we can try this IB inside of the service. Let's try it here. It is the same IB for any server inside Amazon. So it's something that's there by design. And then we read it. So these are all the directories inside it. Many things. Let's use this one, /latest. So I'm going to say latest. And now we have lots of interesting things. Let's try user data. User data, okay. Now we can see we have a script running. This is the default startup script of the server. This could contain passwords for connecting with databases. This could contain some secrets of the initialization process of the server. So it's obviously that this could be something fishy for us to try and exploit. Let's try something else. Let's try, go again back to latest. We have metadata. Let's try this one. Metadata. Now we have lots of interesting things. We can have more info about the IP and the network, the host name of this image, of this actual running server. And we can have some security groups, keys, services. Let's check this one. IAM. Remember what IAM was? It's the Amazon Identity and Access Management Server, the one responsible for permissions. So maybe we can find something interesting inside here. Let's keep on digging, okay? IAM, security credentials. This could be promising. Okay. So let's try this one. Okay, now it's giving me, this is actually the name of the role, the user role that's running the server. So this server could be running with lots of privileges or maybe not so much privileges, depending on the configuration. If they run a server with lots of privileges inside the Amazon environment, and then it has a vulnerability like this, it could mean that we could, from the server, compromise the entire Amazon account, including any other services running on it. So maybe we can see something interesting here. Okay, so code success, as updated, AWS access key and secret access key and token. So this looks interesting, right? We can now see something could be promising. This is actually the key that you can use to log in to this Amazon account using the Amazon API and issue commands, control the servers, control the databases, read data, update files, create new servers. Exactly like an admin, it just depends on how much privileges this was given. So let's keep on going. We've seen this one. Okay, we've seen this one. So what's actually being done here is that we can use these access keys and load them inside the Amazon API to do some malicious things, okay? So I'm going to now introduce something that I talked about before. Anybody knows what this is? So it's a new tool I have written for Amazon, and I have not released it before. I told the conference organizers I'm going to release it in the conference itself. So it's called barq. Barq means lightning in Arabic. That's why you see all the lightning stuff. So this tool is a post-exploitation tool, meaning that you give it an API key and it allows you to attack the services inside the Amazon environment. So you can attack running servers, you can get dump credentials, you can attack all the environment inside Amazon using this server. It's written in Python. That's the actual GitHub link. So you can go there and you can download it yourself, you can try it. So things that this tool can do is dump credentials of Amazon. In Amazon, you can save the passwords and the keys of all the users, all the databases inside something they call secret manager. But there are ways to read things from inside the secret manager, so maybe it's not so secret anymore. You can actually attack the EC2 instances running without even having the passwords or the SSH keys to those running servers. So you can attack them from inside Amazon. You can get like Metasploit shells running on the EC2 servers. You can dump the metadata. And also it has a training mode, such that if you want to try this tool out, and you have a running servers already, you don't want to mess around with them, you can just run the training mode to just get a feel of how the tool works. So maybe you just use the credentials we found. Remember the credentials we found here? Maybe we can just use them inside the tool, and then we can see if we can attack the running AWS environment. So I'm going to run it now. Okay, now let's see the help menu. Let's set our AWS credentials, set profile. Then it wants the access keys, so let's give it the access keys. Now these keys actually get refreshed every hour, so you have to be really quick on how you use them, and then you can just try to backdoor your way. And then we're going to give it the security token. So just going all the way here. Okay, keep waiting. Okay, now we have it. So now we are logged in. What is your default region? Okay, so now let's see the help. We can do lots of things like dump secrets, attack EC2 instances. But we have the training mode. So let's run the training mode, okay? Training mode, help. Start the training mode. Let's start the training mode. In the training mode, the tool will create temporary roles and services for you, so you don't actually destroy your running environment or mess with it. Now it's going to train us, or let's say demo for us, one way to attack the running EC2 servers. So it will create one for us, and then it will attack it. But not attack it from outside, it will do the attack from inside the AWS environment. So what kind of server do you want to create? Linux. It's now going to actually create the Linux environment, the Linux server. It will actually choose the type and the size of servers that are included in the free tier of Amazon, so it will not cost you money. It will be free for you to run and demonstrate. It will take some time to actually run the server, hopefully not too much time. So is it clear what we're doing here now? Okay, so now let's wait for it. Okay, the waiting game continues. You know, demos are stressful for the speakers, right? Okay, please keep going. Okay, so it worked. Now it's telling me what kind of attack do you want to pull on that server. So we have many options. These are, of course, we are the training mode, so it will give you some sample attacks to run. Maybe display the password file, the shadow file, simple commands. Maybe we can have a reverse shell, Metasploit shell. So why don't we, anybody knows Metasploit? Can I see some hands? Anybody tried Metasploit before? So it's like another post-exploitation tool, right? Where you can have access to tools like Metadata agent, which allows you to do lots of internal attacks once you compromise a server. So why don't we try to actually use the Metasploit choice? Now it's going to ask me, give me the IB you're going to attack. So I have prepared the server running Kali in the cloud. That's the server IB. So I'm going to make my victim Amazon server connect back. I will inject it with Metasploit agent, and then it will connect back to my control machine, and then I can just issue commands on the victim server. So the IB of the control machine and the port. Now I can have the what kind of payload I want to run. Let's choose the Metadata reverse TCP. Now it will give me the command to actually paste inside of my attack server, just to prepare the environment to receive the connect back and receive the shell and control the server. So this will also take a few more time, hopefully not too long. Now it's running and waiting for the connection. Let's see if it comes. See if it comes. Hopefully it will come. It takes time, don't worry. Okay. Okay. Let's see. Okay, now we have a connection. Excellent. Okay. So can we some clapping here? Come on. Okay, now let's clap for Metasploit. So let's list all the sessions that we have. We have a session coming from this IB. It's running as root with the IB. This is an internal IB inside Amazon. So you can see that, US West 2. It's actually a server inside Amazon running on the US West Coast data center of Amazon. And it's connected back to our server. So let's connect back to it. Now we can have like a shell access to it. This is actually a shell on Amazon server itself. For example, let's see the IP. This is the IP. This is the private internal IP inside Amazon environment itself. So now maybe you can make the shell back to a Metadata. Let's run some scripts to actually see what we can gather about this host that we hacked. Okay. Run bost Linux. Gather. Okay. So let's check what kind of things we can run on it. Let's try to dump the hashes, for example, the password hashes inside of this vulnerable server. So it's going to actually try and see if it can get me the hashes. So yes, it did. It got me the hashes for these users running inside this Amazon server. Maybe we can try other things. Like, for example, let's see. Enum protections, enum config. Let's see if we can steal any configuration files inside this server. Of course, it's a test server, so it's empty. It's just training mode. So these are the samples of what we can do inside the server once we connected to it. Now it's finding some configuration files and stealing them for us. So now we see the training mode. We can just exit back again to the shell. Now see that training mode is done. It is now terminating the instance, and now it's going to delete everything, clean up after itself. So we can see how we created an Amazon instance, and then we attacked it without even having access to the password or the SSH key pair inside this instance. And even if it was firewalled from inside, such that it doesn't have any public access to the internet, we still were able to attack it because we used the stolen API keys to attack it from inside Amazon to outside, okay? So now we'll wait. Okay, now it is terminating, detaching policy, and the training mode is done. So that's good. Let's see what else we can do. Let's try to dump secrets, for example. Now it will go, this tool will go over all the regions inside Amazon. Amazon is a big, Amazon cloud is a big network, it's a big environment. They have regions in United States, East and West. They have regions in Europe, in Ireland, in Germany, in Paris. They have in Japan, in Singapore. They have in Brazil. They now just started in Bahrain as well. So the tool will go to each region and try to dump the secrets stored in each region so that it doesn't miss anything. It will now go, see for example, the blue color doesn't work well with the projector. So now we have some secrets going on. It detected some secrets. Now let's see what we got. So I'll show the command show secrets. And then we can see these are sample secrets, of course, like database passwords, passwords for Postgres database, test API keys, URLs. So these are the actual, this is the actual place where any admin in the AWS environment is going to store passwords such that other services can go and read them and use them to log into databases, for example, things like that. So we can just dump them like this. We can have another, let's see the help again. Attack surface, discover attack surface of target AWS. This command will go through the entire account and see all the running services inside. Try and see if there's anything, fishy or juicy or interesting to try and target. So it will go again on all the regions, try to discover anything interesting. Let's see if we have anything here. Let's wait. Okay, now we have some security groups. Okay, now we have some instances. So it's got some things. Now if you can see, we have maybe a running Linux server. Maybe you can just target this one. So let's go to Ec2 Attacks, Ec2 instances, and then let's see the help menu. List. Let's list all the discovered instances. We have three instances. One of them is running. The others are actually stopped. So you can see their information, the platform, the region in which they're running. Now let's see and try run some Ec2 attacks. Now it will give me the option either to attack everything in an environment or just use one of them. So let's use two for single. Now it says, give me the ID of that server. So the ID is a bit long, so I'm going to just do tab completion. Now it will ask me what kind of attack do you want to pull on that one. We've seen the Metasploit attack before, right? So maybe we can try to download the Ec2 metadata, for example, or display a file. Let's try number one. Display for me the metadata of this machine. So this is the command. It's actually running, so you can see the command. So the tool will show you what it's doing. It will not hide from you because you, as a penetration tester or consultant, you want to actually know what's going to run on your customers' machines, right? So just tell you what's that. And then we have a response. It's telling me the command's executed successfully. This is the output. So you can see we have more keys we can just steal. Because if I print the metadata of all the running servers, I might have something else interesting in one of the other servers. One of the other servers might have more privileges, for example, so I can use that key and then use the tool again to gain even more access. So I can do, for example, I can run something on all the instances instead. So all of them. Now this is important, so it tells you this is a very risky move. Why? Maybe you have a client who has maybe 1,000 servers running, so you will run this command on all the servers running. So it's really risky to use. Yeah, I will do it because I only have one. Run for me a custom command. Let's see, for example, cat var HTML index.php file. We want to read the source code. It will give me two options, a command for Linux servers and a command for Windows servers. I don't have any Windows servers running, so ignore. Now it will go and run. It will take some time. It tells me, check back with the command called command results. If there is anything, if there are any new results coming. So let's check, and now we have a result. It's now reading for me the source code of the file, the application we told you about. So now you can see the password. It's a very strong password, believe me. So that's basically some of the things you can do with these sorts of tools. You can just pivot inside and attack the Amazon environment. Now let's go back to the presentation. Do you like it? It's open source. You can just go and download it, use it with your clients. Thank you very much. So these are just screenshots of what we did. I prepared those in case the demo goes wrong. So next for this tool, focus attacks on the Lambda environment, create some backdooring features, third-party module support, and the web interface API. So please contribute at this URL, the GitHub link. You can just download it and try it on. So now, let's see how much time I have left. Okay, I have maybe 5 or 10 minutes. So I'm going to speed up on this. We talked about EC2 servers. We have other servers running inside Amazon, and which are now being the focus of many, let's say, new trends in software development, serverless functions. Lambda functions, as we discussed, it's like when you upload your own code to Amazon, instead of having the server itself, you just upload the code and Amazon runs it for you. They call it, of course, serverless, but there's actually a server involved. It's just that it's a very small server, short-lived. It will run for maybe 60 milliseconds, maybe 1 minute, and then it will die after the request is completed. So you don't actually have to manage any server, you just write your code and Amazon does all the rest for you. So because it's still a web application, it's still code, you have the same regular vulnerabilities involved like command injection, things like that. However, there's a special kind of vulnerability they call event injection attacks. Because in serverless, you don't have one big application, you have all functions separated together like separate functions. So maybe in a regular application, you have lots, maybe 10 functions inside. In serverless, each of these functions will be alone running in itself, like a microservice. So now the communication between them becomes really complex, and the order of execution is not guaranteed. And you could have a case where something coming up, you didn't expect it to come to this microservice, and developers, unfortunately, trust too much inside Amazon, so they think that everything coming from inside Amazon will be trusted, and that's, of course, not the case. So in this case, events could be HTTP API requests, upload actions. For example, suppose you have an event, a microservice that would listen on any file being uploaded to S3, and then to try to maybe do a virus scan on it or try to do any processing on it. So that's what we call an event. So these events could result in vulnerabilities where you actually trust the data coming from Amazon. For example, this code, os.system, Cobe from inside S3, from source file to the destination file, right? So this is os.system. It's a regular OS injection attack, right? If I upload an S3 file that's not, that doesn't have a regular file name, but actually has a command as its own file name, it would be able to execute itself as another command and give us access on the serverless environment. Because I don't have much time, I'm going to show this one to you, and you can just try it at home to try and attack these servers. This is actually a running, it's online running serverless application where you can have a vulnerable one to try. It does basic idea, convert a document, a Word document file to a regular text file. Actually, it has an OS injection attack. We're going to see the code. This is the actual code. So now it's running in Node.js. This is the actual application, and this is the binary files inside it, and that's the code itself. You can see that, exec, sync, and then it's running the curl command. So this is vulnerable to OS command injection. If I can upload a file or give it a file name, that will actually do an exploit for me. We're going to see, let me do a really quick demo on this one while we have some few minutes left. So it will ask for a URL to a document file, then just try to download it and then display it as a text file, okay? So why don't I try an OS injection attack, maybe ls, then try and see. Now we have the document itself, and then we have what? See this one? It's the result of running the ls command, right? So maybe I can try something else like cat etc password, and then we have the password file, see? So we can just keep on using this serverless application and giving it more commands to run. Unfortunately, if I try to run a reverse shell, it will die immediately because the OS, the serverless functionality will just live on for maybe a few minutes, and then it will die off. So there are actually more applications like this you can play on. I'll show you another one. This is called DVSA, Damned Vulnerable Serverless Application. You can also run it on your own Amazon account. This one is actually live and running. It's like a video game store. You can just go and buy Pac-Man, for example, and then you submit, and then you will notice that it's actually using a vulnerable S3 bucket that allows uploading. So let's check the source code. What it does is it takes the file, the S3 file uploaded, and then takes its name, and then it will plug its name inside OS system shell command. So if I upload an S3 file that contains in its own name an OS command, it will be executed here as if it was a regular command. So let's see the sample here. This is the upload command I'm going to run, AWS S3 Cobe, an empty file, and then to the S3 bucket, and then I'm going to create, this is all a file name inside S3, but when it's being processed by this vulnerable function, it will stop here, create a new account, and then do a curl, which is like web request, on an IP that I connect, and on a website that I control, and then it will send for me the output of running this command. So it will tell me that I received data from somewhere, which is the serverless function, giving me its own result of executing this function. So this whoami will result in, for example, giving me the user, because it's running the whoami account. What if I did, for example, ls, and then I can just try to list all the users inside, list all the files. Maybe I can try, for example, environment command, env, and then it will give me the environmental variables which could also contain what? More and more access and secret keys. There's also a third sample serverless function that's vulnerable. It's called damned vulnerable function as a service. It uses something else different other than S3, using the Amazon symbol notification service, which is like a notification, like sending emails and things like that. It will actually result in SQL injection. So I'm going to just see a sample of the code. This is the code. Insert into Censor the values, and then it will just give it like regular string concatenation, so it's vulnerable to SQL injection. This function will run as a serverless function, app on SNS message. So this one you cannot call it. You cannot call this one directly unless you send a notification message inside Amazon, and this one is listening on it. So it will read the message and it will try to store that message inside the database. But because it has a vulnerable SQL injection code, you can write your own commands, your own SQL commands, and the function will just add them to the DB, which will allow you to control the database. So this is an example of the function we're going to run. It will just give it some sample SQL injection payloads, and then it will run, and then the result will be that we have in database, we have injected our own strings, our own commands running inside the database instead of the regular data that should have been there. So RDS is the Amazon managed database server. It's the one we attacked here in this sample. It's a database managed by Amazon. You don't have to have a database admin. It's also vulnerable to these types of attacks, but much less effective than usual because of the abstraction layer. Amazon will handle lots of things for you. So even though you can attack it, you can only read the data. You cannot really compromise the database itself as a system. So that's basically it. I'm out of time, and I can't hold you any longer. Thank you very much for interacting and for listening. If you have any question, I'm ready to answer. Any questions? Okay, thank you very much. These are other references. You can just look them up, see all the tools that we discussed about, all the training, the application training that we tried. The vulnerable ones, you can just play on them at your own pace in your own Amazon account. Thank you very much.